All right, so today we are looking at working with text files. We've got something to download, weatherdata.zip. So we've got to download this and extract it. And it's just a set of 3 text files that we're going to be working with. So maybe I'll download that again. I'm not sure where I have to save it. I'll put it in my documents and save. And I'm going to go ahead and get this extracted. We have already extracted it here. Nope. Extract all. Data. Okay, so I have these 3 files extracted. They're in a folder called weather data. And we'll go ahead and we'll put the Excel file that we're going to build at the same level as the weather data folder. So similar to our project, the database project will have the Excel file at the same location as the folder that holds the files that we're going to process. But let's just take a look at these files. Look at one of these files, maybe this first one. All right, so let's kind of take a look at this data and see if you can tell me something about it. It's kind of a strange-looking file. First of all, what kind of data do we have here? This is the monthly precipitation tabulation. So this is records of rainfall, of precipitation. It might be easier if we kind of look down here. That first block is a little bit confusing. Let's go on to the next block, and let's see if we understand what this says. Any thoughts? Look at this and say something about this data. Other than it's data. What can you say?
I sent my mission in Belo Horizonte.
So this is from your mission. What year were you serving?
2012.
Yeah, so this is before you were there. I don't know what it is. This is 2008.
Oh,
so this is before. So what country is this?
Brazil.
Yeah. So these are weather stations in Brazil, apparently. Are these like states or are they cities?
No, Minas Gerais is the state, but all of the other ones are cities.
Yeah, so I think these are places where they're recording precipitation. And so we have here, we're saying, okay, look, for November 1st, there was 7, I think it's millimeters, yeah. So 7 millimeters recorded at this weather station. So good. So that's a pretty good description of this data. If we were to look up, that's the raw data. Up here, it's like percent. So this is the percent of normal. So here's, I don't really know. Normal. Oh, no. So we had, I think it's, precipitation was probably 9 millimeters, and that's 20% of normal. We had 5 millimeters, that was 125% of normal. I think that's what this top is. But the raw data is down here in the next block. And then it goes kind of like that. Raw data, summary, raw data, summary, raw data, summary. And it goes, for quite a while. Now, okay, so that's what the data are. Tell me about the format. This looks like a crazy format for data. Any thoughts on why the data is formatted this way? Does this strike you as easy data to import or difficult data to import? Yes. Well, it's kind of easy to read. It's actually meant for human eyes to read. But in terms of import, it's not like it's a comma-separated file or a tab-delimited file that's just that we can just hand to Excel and say import this. It's not going to be. It's not fixed width. It's not going to be easy to import. So, any thoughts on why we have a file of this format at all? It's really kind of interesting. We have to go back, wind the Wayback Machine to the 1970s, the 60s, 70s. Back in those days, this thought that we would ever want to take the data off the computer and put it on another computer, that had never occurred to us. Why had this never occurred to us? Yeah, if you were a company, how many computers did you have in the whole company? 1. You had 1 computer. Why do you want to take the data off the computer? What are you going to do? There's nowhere to put it. So this idea of saying we want to have some way that we can have some interoperability with this data and put it somewhere else, nobody thinks about that. Why would you do that? You wouldn't do that. What's the main way that you get data out of that system? Read. Okay, what format? What is it? How do I actually read it? Print. Yeah, print. Because there's 5 or 6 terminals for the whole company. We're going to have thousands of people that need the data off this computer. How do they get it? Every Monday morning, a guy goes around to the cart and drops off your printout. Here's a printout from last week. Here's a printout from last week. Here's a printout from last week. You go through lots and lots and lots of paper. And so, this was it was never designed to make an electronic file. And so, now let's roll the clock forward to the late 80s, early 90s. Now, we've got lots of computers, but we probably still have our main system, our, what we call them today, legacy systems. What's a legacy system? It's an old system, but what's the main characteristic of it? It's old, but it's mission critical. We still have to use it. It's really old. And now, we've got lots of other computers that we could be using for doing this analysis. We don't have to even print the stuff out if we could just get this to another computer. So, how are we going to do it? Well, we could hire some programmer paying lots and lots of money to come and actually change the program, probably in a language that nobody knows anymore, and we're just glad the thing keeps running. But then someone had a great idea. They said, look, this thing is built for working with a printer. Well, what if I had a device that I could plug into this like it was a printer, and instead of printing on paper, it printed to a file? It talks to the other system like it's a printer, but it's not printing on paper, it's printing to a file. It makes an electronic printout. That's what this is. And so this became, and remains to this day, one of the main ways that we get data out of legacy systems. This thing's set to print, we're going to print it out. The data that we need to do our analysis is here. We want to chart precipitation over a period of time. Maybe we're only interested in Bogota. We want to chart precipitation there, or for all maybe we want to do a pivot table and do some other kind of analysis on this. We've got to get the data from a format like this into something we can work with. So that's where we're headed. Shall we do it? Yeah, let's do it. I agree. All right. So I've got book 1 open, and I'm going to save it in the same location as the folder that I extracted. Where did I put that? Documents? That's OneDrive. Don't do OneDrive. What have I done? Stop. Go back. Oh, no. Regular old documents. That's the one. There we go. Weather data. There it is. Good. So I'll make this an XLSM, and I will call it import weather data. Now, it turns out that for various other reasons, we've needed to read text files. Have we ever written to a text file? I don't think we've written to a text file. But that's really what we're after today, is working with text files. So, Alt F11, and let me insert a module. In the right place, yeah, import weather data. So let's start off just with before we actually get into reading this data, let's just see what it takes to write out to a text file. So write to file. Here's how and whether we're reading from a text file or writing to it, we have to open it. So let's open it. Open, then we give it the full path of the file that we want to write to. In this case, I'm going to say this workbook dot path concatenated with a backslash, and I'll just call it file1.txt. So this is going to be, we're just going to write to a text file located at the same place that the workbook is located. I'll go right into my documents folder. Now, I open that, but I have to give it a mode that we open it in. So I'm going to open it for output as, and then I give it a number. I'm just going to say as number 1. I'd like to resize this. As pound 1. Then I'm going to close. There are kind of several different ways that we can write data out. I'm just going to show you a simple one. You'll get the feeling for it, called print. So I say print number 1, comma, and then I say what I want to print. Hello. Time is, And then I will print number 1. Now, so that should create a file that just says the time is, and then shows the time from the current time for the system file. This needs to say close number 1. So the idea here is that I could have multiple files open simultaneously. One is called number 1, one's number 2, one's number 27. It doesn't have to be sequential. I can just pick whatever number I want to use. If they were writing these statements today, they would be more object-oriented. I'd create some kind of object, and I would call it open method. But we're going back to the 1970s for when this part of the language was built. And so this is just the approach to working with text files that we had there. So we give it a number, and we use that number to refer to it. So if I run this, I should be able to go to my documents, and I should be able to find file.txt and open it, and there it is. So this is a text file that Excel just created through VBA, and the time is. If I were to run this again, what time does it say? 3:46:47. If I run this again, and look at that, it's now 3:47:13. So it's updated. So when I open a file for output and write again to the same location, it writes right over the top of it. It just replaces that file. What if I wanted to just add data onto the end of it? What if I wanted to append data to an existing file? I don't open it for output. I open it for append. I'm opening the same file now, but I've changed it to open it for append. And now when I run it, it will append onto the end. So it just added those lines onto the end of it. So in terms of writing to the file, those are the two main ways. Open it to write a brand new file, overwrite an existing file if it's there, or to append, you just keep putting stuff on the end of a file. There's another approach that's a little more involved. We won't cover it today. You can open it for random, and that allows you to read from a file and write to it, kind of depending on what you want to do. Read a part, go to a final place, read what's there, find somewhere else, write to it there, and so that's for random. But we're just going to do for output and for append. So in terms of writing to a file, that's what you do. Questions? Yes?
Why should you just go to Notepad++ rather than just Notepad?
Good question. I guess I have Notepad++ set up as the default application to handle that type.
Okay.
But you could just right-click and say Open With. If you have Notepad++ installed, there'll be an edit with Notepad++.
Okay.
So you'll notice that when you print to it, it actually automatically puts a line at the end. You can suppress that line by putting a semicolon at the end. So now, because I entered the semicolon, I think it's going to suppress the carriage return that normally would go at the end of that. So now that, even though it's one statement, it's set up to say you're going to print a line at a time, but you can suppress the line of the carriage return by terminating the line with a semicolon. That's about all I want to cover for writing data. Questions? All right, let's go ahead then and read a file. Sub import weather. Now we could probably be more sophisticated about this and handle multiple files. We've already been through an exercise, a project where you had to look at a directory, look at all the files, process them one at a time, and so we're not going to spend time on that in class today. So why don't we do import weather data, and what we do sub process one file. That one's going to take a path. And all we'll do in import weather data is we'll call process one file and we'll give it a path. This workbook.path concatenated with backslash weather backslash, and then let's pick one of these. Well, it's called weather data. And why don't we do this one right here? Weather data. WSI space 2008 x11.txt. That's the one we opened. We were looking at. One of these has. I'm going to take a peek at this one and see if that's the one I want to do. Two of them have all 5 days. One of them has only 3 days. Yeah, this one will be good. So that's where we want to be. So of course now in process one file, we will have passed the full path to this path variable, and we're ready to open that file. So we're ready now to see how to open a file for reading. It works pretty much the same. Open, and then we give it the path. What do I put for the path? Full path of the file name. What do I put here? Path, right? We're passing this in as a parameter. So we're going to call it from here. We're going to send this workbook path, weather data, this whole thing. That'll be held in the path variable. And that's what we want. We want a full path to a file. So open path for input as number 1. Close number 1, and then work between those. So far, so good? Now, let me show you one way. We've already seen this quickly on a prior example, but let me kind of talk through it right here. Here's one thing that we can do. Let me make a variable called file contents as a string. And I can read this whole text file into a variable. How much memory do I have on my computer? I've got like 16 gigabytes of memory. That is a hot load of memory. Read a huge file. I just put the whole thing into a variable. What's the longest string a variable can hold? 4 gigabytes. One string could be 4 gigabytes. How long is the Book of Mormon? It's like 1.6 megabytes. I can have a string that is thousands of times the length of the Book of Mormon in one string variable, right? So I can have a lot of text in the string variable. Lee.
Content doesn't. I didn't know how many gigabytes the Book of Mormon was.
Oh, yes, that's me. You're saying I misspelled contents? Of course, it's just a variable name. Is that better? So I can just say that variable name equals input, and I'll tell it how many characters I want to read. Let's read 100 characters off of file number 1. So this always seems backwards to me. Something I should say the file that I want to read from and then tell it how long, but it's the opposite. 100 characters from file number 1. Debug.print file contents. And so now when I run this, it should print off the first 100 characters, and that's the first 100 characters. So, what if I want to read the whole thing? I got to tell it how many characters the whole thing is. Fortunately, do debug.print again. I can ask for the LOF, length of file of a particular number. Ooh, I'll have to do this while it is open. This has to go inside the open. So LOF is just part of the VBA language, length of file. I give it an open file number, tells me how many characters there are in that file. So now if I run this, I see there are 33,245 characters in that file. So if I wanted to get them all, what do? Yeah, I just put this call to this function where the 100 is, and that will say now, just read all the however many files are, how many characters there are, I don't care. Read them all. Read them all. And so now that should print the whole file into my immediate window. I don't get to see the whole file because the immediate window is only 200 lines long. So it's pushed off the rest of whatever was there. These are the last 200 lines. Okay, so that's if I want to read the whole thing into a file. Now think about it. Let's go back to the 1970s when this stuff was written. How much memory did you have on a computer in the 1970s? What's that?
1 megabyte.
That would be a lot. 1 megabyte would be a tremendous amount. In the 1970s, computers like the very first personal computer, IBM PC, how much memory it had? I don't know either. But the second one had 640K. So 0.6 of a megabyte. That seems like a strange number. Why was it so low? Why was it so low? It's because when they were proposing it, it was like, you know what, 64K will be enough. And someone goes, you know, we probably should have some more memory. Okay, we'll make more memory than anyone will ever need. 640K times 10 of what we were originally thinking. Okay, so you're talking about, and in that 64,000 characters in memory, you've got to have your operating system and anything else that you want to have in memory while you're working with it. Did we have large files in the 1970s? Files with lots of data? Not large by today's standards, but yeah, we had files that were way more than you could fit into memory. And so, and in fact, do we have files today that are more than you can fit in memory? Oh yeah, text files you might have to work with. And you say, you know what, I can't load this whole thing into memory. Well, that's good news because this was designed for an era when you couldn't put the whole file into memory. And so what we can do is this whole thing is wired up to be able to read one line at a time. And that statement is called line input. I got to remember. Stand by this. PBA line input. So file input. Yeah, line input, and then line input. We tell it what file we're reading from. That's all we have to say. And then we give it a variable that we're reading it into. So this is a little bit different. So let me dim one line as a string. And we're going to read that into one line. Now, instead of printing the file contents, I'm going to print one line. If I've done that right, it should now read in just the first line. Let's see, this one reads the whole file. Read just one line. Okay, so now that should just be the first line. What's the first line look like? WSI Corporation monthly precipitation tabulation. So I'll run this, and we get just that first line. Okay. Now let's see, what do we have to do to get this to read the whole file? Do it, put it in a do loop. Do and loop. Now, we have this LOF, length of file statement. There's also one called EOF. Do until EOF 1. EOF is just a flag. It's end of file. Have I reached the end of the file? It's Boolean, true or false. So when I open that file, you think EOF is true or false? I haven't read it, I just only opened it. True or false?
False.
Yeah, it's false. And then I'll read a line. Have I read the last line of the file yet? It actually doesn't go to, EOF doesn't go to true until you try to read past the end of the line. So you read that last line, it'll still be false. You try to read a line that isn't there, and that's when it goes to true. So now this should be false. I'll read the first line. Better bring the print inside the loop.
So there's something that will
Hold on just a second. When I nodded, I was just trying to let you know I was going to get to here in just a second. So this loop now should read a line, print a line, and then it should come up here, read the next line, print it, read the next line, print it, read the next line, print it. So that should spool off the whole file. One line at a time. Now go ahead.
So there's something in the end of line that keeps track of where you are. It's not just measuring, okay, you're seeing the whole thing, but it's actually like taking record of, okay, they only looked at this.
Yeah, it's not the end of line, or the end of file. Somehow, somewhere in VBA, when I open up this file as number one, it keeps track of, for number one, have I read to the end of the file? I'm not sure exactly how it keeps track of it, but it's keeping track of it. Processing files in this way was so core to the way we did computing when this language was invented. It's just a fundamental part of the language. No objects involved. It's just what the language does by itself. Yeah, there's no property that you can look at of an object. It's just that there's a statement that you can ask, and it will tell you have you been there. So now we've got it all. Okay, so now the structure's in place. But now the task is we've got to write some algorithm that can look at this data one line at a time and figure out have we found what we're looking for. Have we gotten to what we're looking for? So let's take a look at the file. The first thing we're going to need is we are going to need to know, we're going to record the date of all this happens, right? So if we look at this number right here, what does this number tell me? Someone give me the context around this number. Maybe we should find one that you can pronounce. Pora. That's not too bad. Okay, so what does that 14 mean? It's how much precipitation. Okay, keep coming.
Day 7 of November.
Day 7 of November. What year?
2008.
Yeah, 2008, right here. And it's also for a particular station, a particular weather station. That's what it is. It's how much. The point is, there's a date. So when I get to this number, and eventually I'm going to have to come here and read. Aha! I found a 14. I have to record. It happened at a particular station. It happened on the 7th day of November 2008. I want to have that number with a date next to it, and probably also the name of the station. That's probably the file that I'm going to build. How am I going to get the date? Remember, I only get one line at a time. I'm looking at this line right here. Is the date anywhere on this line? No. I'll be able to find the day. When I get to this line, I'll have some notion of the day. Fortunately, it's kind of in the same order as the information is down here. But let's start off by getting the month and the year. So the good news is that this is all going to be November of 2008. In no case do we have data on a report that spans a month. Right? The first one we opened only had 3 days. Why did it only have 3 days? It was like the first 3 days of November. There were some days before that. That was in October. We're not putting those in the same report. So let's start off just by getting the month and the year. In fact, I'll create a variable. I'll call it MOYR, M-O-Y-R, the month year, as a string. I'm going to do this even before we get inside to this loop. I'll just start off here. I'm going to read the first line. This is going to read the first line. Read the first line. Is there any information I need on the first line? I don't think so. So how do I get to the second line? This says read the second line. So at this point, I'm going to go ahead and run right to here. Put a breakpoint in code, stop. Run this. Now I should be able to look at one line, and it should have, it has that second line of the file in. I now have a string that has this stuff right here. So how do I get the month and the year? You know the statements we need to do this. What are they?
In string.
In string. All right, so I'm going to declare another variable. I'll just call it position as an integer. One of my favorite variable names in Assembly. Position equals instr. Start the first character. Look at one line. Look for what? Now we've got to think about this. Is that I have to write something that works not just for this file, but for any file that gets exported from this system. So what? I got to think about this. What could possibly be something that I could look for that would be the same every time? Hyphen. Yeah. I don't know. It looks like they got the whole thing spelled out. So if they're going to put December in there sometime, it's probably going to be longer. I can't just go to the particular character. I don't know what this number is going to be. I might be able to look for 2, T-O. Is there any month that has T-O in it? October. Oh, that'd be bad because October's got T-O built right in the middle of it. I can't look for T-O. So, but I'm probably safe looking for that hyphen. So I'm going to look for that hyphen. That's going to tell me where that hyphen is. So now I'll just say mo year equals, someone do it for me. What statement should I use to pull out the month year? In-string tells me a position where I find one string inside another. So in-string is not going to help here. What was it? Mid. Start where?
POS.
Oh, I need to give the string. Sorry. Yeah, so one line. Start at POS and take how many characters?
-2, though.
Oh, well, so here's the question. The question, so this is going to be, the pose position. Do I want this 10?
No.
No. The 10 part of this comes in down here. That's where I'm going to pick up the 10. So I don't need the 10. So I need, yeah, just need the month and the year. That's why I call it the variable mo year for month year. So how many characters do I have there? 1, 2, 3, 4, 5, 6, 7. So I'll take 7 characters. What's that? Okay, so now I'm going to go ahead and run these 2 lines, and I'm going to look at mo year. Did I get it right? M-O-Y-R. Yeah, I got it.
You want the hyphens in there still?
Question is, I want the hyphens. Ultimately, at some point, I'm going to get a 10. And I'm going to drop that 10 right on the front of this. Or I'm going to get a 7. I'll drop the 7 right in front of this. If I don't pick up the hyphen now, I'll have to put the hyphen in later. So I'm going to go ahead and pick up the hyphen. It's convenient. But yeah, I can take it without the hyphen and then compose it later. Okay, so far so good. It's been a lot of work so far, but I now have the month and the year off of this file. And that's going to be the month and the year for every number inside this file. So I've got that. I'm done thinking about month and year. Lee.
What about like June? Because that's like 4 characters, right? Instead of...
Oh, that's a good question.
Does it just put June in?
Well, I'm pretty confident about that because November has 8 characters,
Right.
and they've chopped it down to 3.
And I get...
But it's a good question.
Back to the line which it was. So... Okay. Yeah.
So here they've said June to this. So we're saying we're starting with June, and we're going right up to November 8th. This is for this summary data. We could pull it off of here, because here's what it says, 4th of November to 10th of November. We could pull it from here, or we could pull it from here, but it's kind of convenient to pull it off just the second line once we get there. So the real answer to that, the question is, how do they abbreviate June when it comes into here? And the answer is, we don't know. To be sure, we'd have to go look at a file from June and see how it's done. But for all the files we have here, they're gonna abbreviate into 3 digits, 3 characters. And I think that's probably the way it's really done. Okay. So what else do we need? We're going to pull this data. That's going to give us, we got the month here. Do we need anything off of this block, this top block that's kind of complex? No. It's all summary data. It's giving us percentage of normal. We don't care about that. I want to come down here, and I want to read this stuff. So what is the next data that we need? Where is the next data that we need? It's on the screen. I haven't gone past it. It's not on this line. It's not on this line. We need this data, but we've already got it. So it's not on this line. It's not on this line. It's not on this line. Depending on what we're doing, we might want to pull the actual word November, but you can infer that from NOV that we've already got. How about this line? Is there data that we need on this line?
Yes.
Yeah. The day parts of the day are here. So now, here's the trick. Now, we got to do something that lets us read past a bunch of lines. The trouble is, we don't know how many lines. We don't know how many lines we have to read. So how can we know when we've gotten the correct line? Is there anything about this line that's different, that's unique from any other line? Well, and is the same, that when we get down to the next one, it's something about it that's the same. Actually, it's exactly the same.
Starts with station.
Starts with station. Well, it starts with like space station. Space station. No, it doesn't do it because we got the same structure right here. Good guess. Anything else? If it's not how it starts, maybe it's how it ends. Let's look at it. Norm. This one, this norm is abbreviated here. I think it's the only line that ends with norm. Last 4 characters are norm. Is there a space after that? Looks like there's no space after it. So that's pretty good. Anyone here named Norm? You get a gold star today if you haven't been named Norm because we're using it. Okay, so now we've got the first piece of data that we need, and now we've got a loop here. You know what? I'm going to leave this loop as an example, just the way it is, and I'm going to comment it out. Well, I'll just leave it in because we probably won't even get to the end. So now we want to read until we find something. So I'm going to do a do loop. Inside this loop, I'm going to read one line. And I'm going to read that line until what? Put it at the top or the bottom. It doesn't really matter. I just put it at the bottom. Until one line. Until one line ends with norm. How do I say that? Until the right of one line, how many characters? 4 is equal to norm. I think it's all capitals, isn't it? Yeah. And so once I hit this, I'll just sort of come back up to the beginning of this loop. Once variable not defined. Well, so I'm going to run that now. F5. So it's looped through that a potload of times, and if this works, how can I tell if this works? Well, let's look and see what's in one line. What do I expect to be in one line? Line that ends in 1. So far, so good. So now it read through a bunch of lines until it met that condition, and now I've got that set of days that I need. That's going to be the same set of days that I need for the whole thing. So let's pull those off and put them into an array. It's going to be anywhere between where it says call and then where it starts with total. I think I could probably, well, that's one of the nice things about Notepad++. I can just kind of come right out here, and it'll tell me what row I would call. That's column 22. If I go back to column 20, yeah, I think I'm probably safe starting there. And then I'm going to run right out here to like column, oh, you can show what I have selected. Look at that. Oh, it probably takes 40. I start at the 20th character and take 40 characters. That's going to give me the numbers I need. It's also going to give me a bunch of spaces, but we'll deal with those. So let me declare another variable. Dim days as, let's do this as a variant. And then I'm just going to read that part of norm. Days equals the mid of one line, starting at the 20th character and taking 40 characters. So I should be able to run that line, come up here and look and see what days is, and there I've got just my days. I got extra spaces. How do I get rid of the spaces? Oh, we'll get there in a second. Trim will take off the first and the last one. I might as well do that right when I read it the first time. Whatever beginning and trailing spaces, forget it. Trim, and we'll get rid of the, run that again, and then look at days. Now days doesn't have the beginning or the trailing spaces. Now, we got to get rid of all the spaces in between. 4 spaces, pretty good. 4 spaces. 4 spaces between all of them. Oops. 3 spaces. That's right, because if I put 4 spaces between all of them, I got more or less going to shift over, so I got to keep them in there. Oh, how am I going to do this? There's a couple ways I can do it. You want to see the simple way or the more general way? more general way is not that much harder. Do it more general way. So let me talk about a simple way. What would happen here if, never mind, simple way is not so simple after all. If I deleted every instance of 3 spaces, 3 sequential spaces, all these would go down to 1 space between, but then I would have run my 9 and my 10 together. That's going to be a little more difficult to deal with than I was thinking. So let's do this. Let's come here and let's just say days equals replace days, look for 2 spaces, replace it with 1 space. So that's going to take all my, it's going to take all my 3 spaces, knock them down to 2, take all my 4 spaces, knock them down to 3. Well, it's okay. I've just made it a little bit better. Then what can I do again? Do that same thing again. I've knocked my 2 spaces down to 1 space, and my 3 spaces down to 2 spaces. Do it again. I've knocked all the rest of my 2 spaces down to 1 space. You can probably just do that in 3 steps, or I could write a loop. I could say, now do this until, how can I tell when I'm done? So each time this thing loops, it's going to shorten down my sequential segments of spaces by 1. How can I tell when I'm done?
Can't find 2 spaces.
Can't find 2 spaces. So do until in string, looking at days, looking for 2 spaces, starting with the first character, sorry. Looking for 2 spaces until that equals 0. UNTIL in string. What is in here?
Do loop.
Oh, thank you. Do loop until. So now that should run until it's collapsed all those spaces. Let's take a look. I'll run that loop. Look at days. And now days is all those numbers separated by just 1 space. Aha. Now split is going to be a breeze. So now I can just say days. This is why I made a variant. Days equals split. Split. Days. I could tell it the character to split on, but as it turns out, that's the default character. If I don't tell it what to split on, it's going to split on space. So I'm just say days equals split days. And now, if I run that and tell it to print days, what's going to happen? Error. Why can't I print days anymore? It's an array. I can print days sub 0. What should days sub 0 be? Should be 4. Hey, look at that. Days sub 6, 10. We got them.
Where does that put the space? Before, after, is it deleted?
Where does it put the space? The space is the delimiter. Space is poof. Space is gone.
What does split do again?
Okay, so split, remember split's just a string function. You give it a string, it looks at that string, and it splits it up into an array of strings, well not, probably an array of variant, based on the character you give it as a delimiter. So up here, we've got days, looking right here with spaces between it. We're saying make an array out of that by using the space to determine where to cut up the parts. And if we don't put the space, the comma space in there, that's the default. It's an optional parameter. It assumes we're going to split it on a space if we don't tell what to split it. So now we've got an array with all the dates. We've got the month and the year. We've got an array with the dates. Whew. And we still got 25 minutes. Next piece of data, how are we going to find it? Let's hold this up. Any thoughts? We want to move down from here. We just need to move down until what? What's going to get us to the right place? Dollar sign's tempting, but I'm seeing something besides a dollar sign on some of these. That means something. I don't know what it means, but it means something. And I bet if we look down, we're going to find one of these that doesn't start with a dollar sign. Yeah, there we go. There's a star. So a dollar sign's not going to do it for us.
So do off the tree stars? The entire line is
Okay, so we could go from here a couple things we could do. In fact, you could say, look, let's go until we find 2 blank lines. Then we're ready. We could go until we find something other than a space in the first character. Anything besides a space, right? All the rest of these, space, 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 space. So we could do that. But I think there's a simpler way.
Just count the lines.
I think you just count down. I think that there's always going to be the same amount here. So if I read the next 1, 2, 3, 4, 5, I'll probably have my next line queued up. So I should just be able to do, let me give myself a control variable for a for next loop, dim x as an integer. Byte would have been plenty, but now we'll say for x equals 125. Next, and we're just going to read the next data. Line input. Advance to the precip data. So I'm going to run that block, and now my one line should have the first set of precipitation data. Is January the one I'm after? Yeah. Aha. What strikes you about the format of this line, the data that I want from this line, and what I've got here? It's exactly the same. I didn't have to think about it. Well, I think about it a little bit. I've got days, and make one called data. Dim data as variant. I'll just copy this whole thing right here. I'll bring it down again. I might even just do a find and replace. Look for days. Replace it with data. Place all in the selected text. I've now got data holding what I want to hold.
Put data as variant.
I did data as variant, same way we did days. It's kind of a lot to do quickly. So here's the data that I just brought in. I literally just declared a variable called data. I copied the block of how we did days. I brought it down, and then blindly just did a find and replace for my days. For my data, the actual data.
So can you show me what you copied and pasted?
Yep. What we copied and pasted is right here. Right here we looped until we found norm, then we were queued up and ready to go. Here we looped 5 until we had the data queued up and ready to go, and so we want that next set. Next block. We bring that up and run it, and we should now have data should be an array done the same way. Data sub 1 should be 0. Data sub 0 should be 0. Which one has a number in it? 0, 1, 2, 3, 4 should be a 9. So we hold that data into an array. And here's the part that we just built. Questions?
Is there a for loop after this part you just built, or is it only before?
There's not a for loop after it. Yeah, the for loop is just getting us from that header line down to the data. Okay. So now I've got everything I need except for the name of the station. I might pull this number off as well, but that's more than we need to do this example. So it looks like I just need to start at the second character and take 12 characters. And that should be able to pull that in. So let me go ahead and make a variable for that. Call it station as a string. Dim station as a string. And station equals the mid of one line, starting at the second one and taking, what did I say, 12? And let's go ahead and trim that to get off any trailing spaces. Should have a station. Got my station. I'm ready to write this first block of data out to my worksheet. Let's see, I've got a variable that will allow me to go across. I've got an X, but let me go ahead and declare a variable called R to keep track of what row I'm on. So back up to the top, we dim R as a long integer. Now, I need to write out a new row for each number. Because I'm going to say, here's the station, here's the date, and here's the precipitation. That's what I want to put out. And so, let's do this. For x equals 0 to the upper bound of data. R equals R plus 1. And we're ready to write this data out. So, cells, we'll just write whatever the active sheet is. Cells, row number R, column number 1, its value is going to equal, what do we want to put first? Station. Column number 2, we want to be the date. So what's that going to be? Days sub x. So the first time through the loop, it'll be sub 0, the first spot in that array, concatenated with mo year. That should give me a date. And then my third column, I just want to be the precipitation. And so that is data sub x. So that should write out the first block of data. There it is. We now have January for each date. Oh, you can put those in as dates. Just recognize those as dates and convert them to dates. Very nice. And then we've got the data. Whew. How are we doing, folks? How many are going, I think I'm following this? Oh, it's cute. How many are going, I quit trying? Yeah, sorry about that. Okay. At this point, we've done all the heavy lifting. Now it's just a matter of making loops to figure out how to control this so it goes through the whole file. Let's take the questions, and then maybe we'll look at this code that we have a little bit more, and I'll just try to follow up that question.
So, assignment's due tonight, right?
Yeah. That was a question? I think the assignment's really easy. Should we take this time to look at the assignment and make sure I've told you what you need to know?
I think it might benefit everyone who's probably something else.
Let's at least read the assignment.
Reading one line.
Yeah, there's a file here. Read the first line off the file and
It's
print it
just
in the
like
cell.
read one line. Yeah, you already did it actually.
Yeah, so I think here's the magic. It is line. It's right here. It's open and it's line input.
Yep. Very good.
I was thinking it'd be more like,
Like this? Yeah. Remember, the homework assignments are actually designed for you to do before class as an exercise to engage the material. How many of you have done this assignment already? Wait a minute. How many of you did it before class today? Okay, good. Yeah, that's the idea. But I realize you got other things to do in life, and this may not be your top priority if you want to just learn it in class and turn it into it. Okay. For those of you that are kind of struggling with the whole approach, you want to talk me through what you understand so far? And it might just be, the dim statement. That's you're good to hear. We're okay with opening? Okay? That's all right. We've got the video. You can go review it at some point when you actually need this. What's really going to happen, folks, is that someday you're going to go, oh, I got to parse this text file. I wonder if that video is still out there. We'll go pick it up. Here's the most important thing. Do I talk about this at all on the final exam? I don't remember. I don't think so.
You've already submitted the final exam, haven't you?
Yeah, I didn't really review it. This is the one I did last semester. It's a good question. Is it in the study guide? Let's take a quick look. Because the truth is, if it's not on the exam, I'm not that concerned about you learning it before the end of the semester. You've got the video, you've got the text. Kind of giving you a walkthrough here. Chapter 15. Let's just look for file. It would definitely say file. Input back, it's just a variable. For a minute there, my heart sank. I thought, did I open the final? Are we looking at the final? This is the study guide, that's okay. We're opening workbooks, that's it. Looks like we're not even doing this on the exam. Okay, kind of feel like those of you who are still with me are like not that much with me. Do we want to loop so we can get this thing to process the whole file, or should we call it good?
Let's call it good.
I am totally not opposed to ending like 17, 12 minutes early. From here, it's just a matter of saying, I now need one more loop to read to my next top. Right? Until I find the next norm. Yeah, so I just need to do another loop until I find norm, which is already the top of this. And then the thing's ready to run. It gets a little bit sticky to actually figure out how to end. Because you're going to keep looking for norms, you've got to find out a way to go, oh, I'm at the end of the file. Now go ahead and, yeah, I'm not going to find norm. So, somebody was saying, if we can do it in 5 minutes, we should do it. Somebody was going, let's get out of here. Okay, so what we're going to do. We're going to dismiss class, and those of you who want to see it, come gather around, and we'll finish. Folks, remember, one more thing, TA. Yeah. Will you please email today the whole class, because we have a lot of people not here today or last time. If we end up with a class GPA that's below what I'm allowed to have for the whole class, I'm going to start shifting grades up to get people up until I get the deep distribution I need. But you don't get to play, you don't get to participate in the shift unless you've given me a course evaluation. So BYU course evaluation. Yeah, and if I go to rate my professor and I see at least a handful of chili peppers, I'll feel good. Remember, it's the robe. It's in the right color.
And we're dropping 2 homework assignments.
Dropping 2 homework assignments.
Okay.
So participation in the grade shift is contingent upon doing the BYU?
The BYU,
Okay.
yeah. Now, there's no way I could know if you did the rate my professor.
Okay, just if there's lots of chili peppers.
That you got to have at least 20 chili peppers too, or no one gets a grade 1. No, but yeah, I guess they let me know who has done the evaluation just so I can give you some credit for it, and that's how I'm going to give you credit.
Okay.
I may not give you any. I don't know, but every time I've done this in the past, there's been some room to shift. All right, class dismissed. Oh, thank you. Finish off this example, come gather around.
I decided I want to stay.
So right here is where we're looking for norm. So if I put another loop that starts here, and a loop here, this should give me the next block. So I'm going to run it until I hit this next stop. And it's brought in the next one. Oh, wait a minute. No good, because that got me the next one of the next block. I've got a whole block I have to read. So I've got to do That's pretty good for finding the next norm, but I need to do something else in here. So here's where I'm reading that one line. And I'll have the days. So that's just, we've got to pick up the station right here. So here is beginning of processing one line.
Do you want to see this?
Sure. Here's end of process one line when I stop this. So here, I'll put a loop. Yeah, this is crazy level of nesting of loops here. Do here.
Now you're going to grab all the data.
Okay, so let's just think about it. So where I am right now, actually on my page, I'm down to the next one. So I think I just pulled in this one. Is this the one I pulled in? Yeah. Low 2-4. Okay, so now I think I just want to keep doing this until I get a blank line. I want to keep doing one line at a time until I get a line that is. Oh, I need to. Okay. So here, I'm assuming my one line is my next one line. So at the end of this loop, where I've printed all these out, I'm going to do another reading of one line. So now I'll have the next line in. I'll loop up and pull the next one. Let me go ahead and run that one once. It should give me the next one below it.
So I thought it,
Looks like I got the same one twice. Oh, that's because I didn't execute this line on that time through. So the next time through this, it should pull the next one. Yeah, so now I've got Franca. Okay, so this looks pretty good. This is processing one line. This should find the next block. R is 92. Station is. Ooh, I pulled in the station. It's blank. Let's take a look at what the bottom of this data looks like. Somehow I pulled in this as something to work with. Let's look at what data I did here. So for some reason I got to Sao Paulo, which I think is the last one, but my control loop didn't work. It didn't get me out. Oh, so I found. I'm going to stop this and start again. So I want to get to here. All right, so that should give me the very first data line. Oh, I'm probably writing over the top. Okay, I've got Padera. Now, how far do I have to go on this first one until I'm on the left, the very last one? I've got to get until this one. I can't even say that. That's Portuguese. Okay, so I'm on the last one. Now this is where I want to get out. I've just printed one line. Oh wait, where's my exit? Do I have an exit on this? Oh. Oh yeah, that's the problem. I haven't put an exit clause in it. loop until, and this is until I get to a blank line.
I like to look at it and tested it.
So until you have more than 2 spaces or something?
Well, let's look. So I've printed this off. I've read the next line. So here I should be. I should have the line that I'm trying to look at. So let's just ask for the length of one line. It should be 0. Yeah, so let's just loop until, yeah, I said the constraint, but I didn't type it in. Until one line is equal to a 0 length string. Which it should be now, that should let me out. And so now this one should find the next block. And it looks like I'm printing now the right one. Okay, so this is pretty good. So this is now going through, and it's found the next block, it's reading that whole block, and we're pulling all the data. So Letitia should be the end of one of these blocks. There's Letitia at the end of one of these blocks. So now the only thing I have to do left is I've got to figure out how to actually for sure end. Because the way I'm doing right now, when I get to this very last block, I'm going to come in here and I'm going to look until I find norm again. So while I'm looking for norm in all the wrong places, I've got to do something to figure out when I hit the end of the file. So which one is going to have me looking for norm? Where am I looking for norm? It's at the top, isn't it? Right here. So I line the input right here. And so after I've read that line, if that was the last line of the file, I need to know about it. So if EOF 1, then stop. Now this got to take me to a breakpoint there once we get there. Turn this stop off.
That's right after the norm, EOF.
Yeah, no, it's right after I read. We go back to that. It's right here. So I do the line input. This is the one where I'm looking for norm. I keep reading until I find norm. But as soon as I read that line, I mean, ultimately to the end, but there's no more norms. And so while I'm in this loop, it's going to take me to a blank line. It's going to take me to the end of the file. So when I read that, I want to check for the end of the file. And so now I've hit the end of the file. Saumlaki. And that's the very last one. So now instead of stop, I just want to be done. How do I be done here? I guess I can just exit sub. I'm done. That'll cause me to reset the code. Whew. Delete all the code out there and run the whole thing again. So now, the key thing is that this is the one that's advancing me through the file until I find the next block to work with. That's the one that's going to fail when I get to the end of the file. So I'm checking for end of file right there. It's not simple code by any stretch of the imagination. But I've now imported the data from this file. And if I had a loop set up to be able to bring data in from the other files, it would just run the next file, the next file. I've now got data that I can graph. Some of these are missing. Trace, I'm not sure. I probably have to do something with trace, maybe change it down to 0.001 or something. But we could work with it. But that's the process of just kind of working through text files to be able to pull the data. And I'll go ahead and post this lab. We made it. Class dismissed.